So we are going to start a brand new topic on probability. I'm pretty sure that you knew that this was coming up because you're in a data and probability connections class. So let's just talk about what probability is. And before I even go into how to find probabilities and how to assign numbers to probabilities, I'm going to tell you that you kind of already know what probability is and how to find it in different ways than what we do in this class. Before I even go on, the term probability is useful, but I kind of like the phrase chance and uncertainty. Okay, because when we talk about something happening, there's a chance it could happen. Like, for example, flipping a coin, there's a chance I could get tails. But it's also not certain that I will get tails, right? It might not actually happen. Okay. The second thing I want to talk about probability is it's kind of like a spectrum. Okay, and it's not just like a continuous one. It actually starts at 0% and it ends at 100%, right? Okay. Now, probability, when we talk about if something's likely to happen, not likely to happen, something can't be a negative percentage of happening, right? That never happens. And we also can't be like 105% unless we're talking in like the figurative sense, right? Okay, now. All right. Before we go into assigning numbers to probability, we're going to do a little activity that kind of brings out how we already know how to do probability and how to assign things on a spectrum. So I'm going to have you get into groups of 2, 3, or 4. I have the same sort of spectrum here up on the board. Hopefully no one's on Zoom. I will give your group a word and you will stick this word on this spectrum from 0 to 100, 100 being very likely, 0 being unlikely, and try to match these. Remember, we don't assign numbers to things when we talk about something happening or not happening. We have words to describe them. We use them all the time. For example, we have impossible at 0. Does everyone agree that impossible is something that has a 0% chance of? That sounds about right. I literally just watched the version of Cinderella with Whitney Houston and Brandy yesterday because of this. But there's this song that says impossible. And that was an example of something that could happen. But usually impossible is something that is 0% not going to happen at all. Okay. Let's go to the middle here. In the middle, I have 50-50. Does everyone agree 50-50 goes in the middle? That sounds about right. Okay. So we've got, I'm going to kind of tilt this to the side, but in the middle, we have 50-50. Okay. Heads or tails, 50-50 chance. Okay. Why don't we do the 100%? So I have definitely and certain under 100%. Everyone agree with that? Yeah. I honestly don't know how to spell definitely. I always mess this up, but I think it's definitely. Okay. And we also have certain. And those are things that pretty much have 100% chance of happening. Next, let's go here. We have slim chance, very close to 0. Everyone agree that slim chance is something that isn't really going to happen, but it might happen. Yeah, I agree with that. So slim chance. Over here. You know what? I'm going to go over here. We have a fat chance. Anyone agree, disagree that this one goes closer to the 100 side? Anyone disagree? I actually kind of disagree with this one, and maybe I'm just wrong. But usually when I hear the term fat chance, it's usually something that isn't likely to happen. But since everyone kind of agrees with me, I'll put it towards the top. Oh, yeah.
I think the way that you would hear it would be sarcastic. So then it's like they're saying, yeah, fat chance. But in reality, like when someone's actually saying, oh, there is a fat chance.
Yeah. That does make sense. I'll just keep it where it is. So yeah, I am not very good with language. That's why I'm a math teacher. But let's put that here then. Yeah, I would say that's kind of like, it could go either way based on the connotation of how you're saying it, but thanks for that. All right, since we're on the chances, we have Buckley's chance. I got this idea from an Australian person, which is why this one's up on here. Anyone heard of Buckley's chance? All right, can someone ask me if I'm gonna win the lottery tomorrow? Buckley's chance. It's something that is really close to 0%, but it might happen, but there's a really, really, really low probability of it happening. So Buckley's chance is something that might happen, but it's really not gonna happen. Okay. All right, let's go towards the right. We have quite likely, really close to, it's about like 80% on the scale. Does everyone kind of agree with that? I agree with that too, right? If something's quite likely, then it probably will happen, but there's also a slight chance it might not happen. Okay, so quite likely. For example, it's quite likely that you are going to get 100% on your test, right? All right, and then we have sure. Sure is about 70% the way through. Is everyone pretty sure about that? Right. I think that makes sense. Sure is about, it's less likely than quite likely, but it's sure to happen. We have probable under 50%. Anyone agree, disagree with that? I agree with it, right? Probable, if something is probable to happen. Honestly, I think it might even be bigger than 50-50. Usually if something's probable, I'm leaning towards the fact that it might happen. So maybe I'll put it like right next to 50-50. Okay, so something is probable to happen. The last one I do want to talk about is possible. Okay, possible. That one was in the middle. Now this one's a little weird. Anyone want to agree or disagree with this one? Madison.
I would say we're probable it's gonna be
On the other side.
like a little less than
Okay, I agree with that. Anyone else? I would say possible could go anywhere, and I'll give you an example why. How about next week? Let's say you didn't show up to this class, and next week you email me and you say, hey, can I take my makeup quiz? And I'm like, yeah, that's possible. That would be something over here, right? Because yeah, it's possible that you're going to take the makeup quiz. Of course you are. Okay, let's say you didn't show up for class at all the entire semester. And on the last day of class, you email me and you're like, hey, can I take test 1, test 2, test 3, and all the quizzes right now? And I'd be like, yeah, that's possible. What does that mean? Yeah, it's definitely not gonna happen, right? I'm not gonna print out all the tests and make you do it all at once. Okay, so possible is something that could go pretty much anywhere, right? Or it could be something that's 50-50. So I'm just gonna put in the middle, but it really could go anywhere depending on the situation. Okay. All right. So we have all our words on here. We already know how to assign probabilities to things using words that might not be specific percentages, but they do lie on the scale, okay? Next, what we're gonna do is we're gonna find out how to quantify probabilities. So we can be even more precise than saying it's impossible, or it's quite likely, or Buckley's chance, right? And the way we're gonna do that is we're gonna use numbers. Types of numbers can be percentages, 0 to 100. And even in the middle, we have our 50%. But usually in math classes, we don't use percentages because, well, they're kind of bulky to deal with. There's a percent sign, the numbers are big, we don't really like using it. So instead we use fractions and decimals. Let's work with fractions first. What's 0% as a fraction? 0, right? You could say 0 over 100, but that's just 0. Okay, so it's just 0% without the sign. What's 50% as a fraction? 1/2, good. And what's 100% as a fraction? 1, good. Okay, so whenever I talk about these percentages using fractions. I'm using this terminology where 0 is the least thing that can happen. 1 is the most likely thing that can happen. Okay. We can also use decimals. What's 0 as a decimal? 0. What's a half as a decimal? 0.5 or 0.50. And 1 as a decimal is 1. Okay, so this is the terminology. Fractions and decimals is usually what we use for probability. Now we will use percentages sometimes, but usually we go in the fraction and decimal area. Some more notation. Saying the probability of flipping a heads, for example, is 50%. That's a big string of words, and mathematicians hate writing things down. This is why I can't spell the word definitely, because I'm used to writing things in shorter notation, okay? So instead of saying this big bulky phrase, I'm just gonna use the word, the letter P, and this stands for the probability. Okay, so the probability, I'm going to use parentheses to say the probability of, okay? And I'm gonna put what I'm interested in the middle. So the probability of heads, okay? Instead of saying is, I'm gonna use an equal sign. And 50% is bulky, so I'm gonna use 0.5. Okay. So I have taken this phrase and I've turned it into this notation that I'll use a lot. P just stands for probability. All right, some more vocabulary I want to go over. I'm not going to be using this vocabulary that much. I do have the definitions up here. We're going to be focusing on variables that can be described with numbers mainly. So we're kind of going to stray away from getting a heads or tails and instead focusing on rolling a 1, 2, 3, 4, 5, or 6. Okay. We call any like possible outcome that can happen, like rolling a 2 or rolling a 4. We call that a random variable, okay? And what this represents are numerical outcomes. So quantitative data, right? Things that can be expressed using numbers. Now, what type of numbers, right? There's many different types of numbers. We got whole numbers, we have fractions, we have decimals, things like that. Two types of ones I want to go over real quick. We have discrete random variables and we have continuous random variables. I want to start with continuous first. So let me explain this guy first. Okay. Continuous random variables are things that can be used and described using fractions and decimals. Okay. For example, the height of a randomly chosen college student in feet could be, I don't know, 5.6 feet, right? That could be an answer, right? Or maybe 5.8. Since we can describe the height of a college student using decimals, it could even be 5.825, right? This is an example of something that's continuous, okay? So we can describe using decimals. Another example is the amount of electricity used to light a randomly chosen classroom, right? These values can be expressed using long decimals, fractions, anything that we want, okay? On the other hand, we have the discrete random variable. Okay, these can only be described using whole numbers. So 1, 2, 3, 4, 5. Okay, for example, the number that comes up when we roll a die. I can't roll a 1.5, right? So because I can only express this using whole numbers, this one is a discrete random variable. Another example is the number of siblings I have. For example, can I have 1.2 siblings? No, right? Because that can't be described using a decimal. So that's why these two are discrete random variables instead of continuous random variables. Any questions so far? All right. I know I'm throwing a lot of words at you right now. We're going to focus on another type of vocabulary word that I'm going to use. Let's say I do something a bunch of times to see what happens. That's an experiment, okay? And let's say I do a bunch of stuff and whatever outcome comes out, that's an outcome, right? Now, there's many different things that can happen in an experiment. And if I think about all the things that can happen, that's what I call a sample space. Now, I know this is slightly confusing in the abstract, let's do a few examples and see if we can identify what a sample space is. Let's say I toss a die, okay? What outcomes can I get? 1 through 6, right? I can get a 1, a 2, 3, 4, 5, or 6. That's my sample space. All the possible things that can happen are in my sample space. Okay. So when I write this out, since I have a group of different things, I'm going to put them in curly brackets. That's usually the notation that we use. I'm not going to strike you if you don't put curly brackets, but we have 1, 2, 3, 4, 5, and 6 in a group. Now that I know all the things that can happen, what's the probability of getting a 2? 1 over 6, right? So I'm going to take everything that I'm interested in, so the number of times what I'm interested in happens, and I'm going to stick it over all the things that can actually happen, okay? So this is all the things that I'm interested in. The thing on top is everything that the number on bottom is everything that can happen. The number on top is all the things I'm interested in that can happen. Okay. All right, another example, we have a coin being tossed. What's my sample space now? Heads and tails, right? Those are the only 2 things that can happen. So heads and tails. Okay. Now, I already kind of went over this with you. The probability of getting a head is 0.5. Okay. Let's do a little harder example. I'm saying harder because there's a lot of words going on here. So let's read through this and see what happens. Let's say we have a polling company and they polled 300 people. So that's a lot of people. And they asked them if they would vote for something. So after they did the interview, they figured out that 123 said yes, 134 said no, and 43 were undecided. They wanted to vote yes or no. Okay. All the outcomes are equally likely. Can someone tell me what the sample space is? Not quite.
Yes, no.
Yeah, right. The sample space consists of everything that can happen. Now, of course, there are 300 total people, but the things that can happen are a person saying yes, a person saying no, and a person saying undecided. Okay. Next question. What's the probability of getting a yes? Or how would I find that? Kayla? Perfect, right? Because there are 300 responses, and out of the 300, 123 said yes. So the probability of saying yes would be 123. Any questions on that? Now, using our notation, we can say that the probability of yes equals this value. All right, let's go on. More notation that I'm going to be using, and I'm sorry, I'll stop throwing notation at you soon. But one other thing we're going to talk about is the probability distribution. So probability distribution. Okay, now we're using the word distribution. It means a little bit different than those graphs that we were looking at in the last section that we worked on. And this distribution is going to be basically a chart, okay? And it's a chart that has everything that can happen, their probabilities, and the chart has to make sense. And when I say make sense, I mean the chart has to follow 2 properties, okay? The first property of a probability distribution is when I look at my probabilities, all of them have to be between 0 and 1. I can't have a negative probability because that wouldn't make sense. And I can't have something that's like 105% going to happen, okay? So the way I'm going to write this is I'm going to take my probability of X for now, and I'm going to sandwich this between 0 and 1. I know the probability can't be below 0 and it can't be above 1. And because I'm using this letter X here, which just is anything that can happen, I'm going to say for every value of X. So for everything that can happen, its probability has to be between those two numbers. Okay. The second property of a probability distribution is when I add up all the probabilities, that means the probability of everything happening, the probability of everything has to be equal to 1, okay? So the way I'm going to write this is the sum of the probabilities must add to 1. So if I add up all the probabilities, I should get 1. Okay. Now, there are a couple of things I want to talk about with these properties. When I have a probability distribution and I want to figure out if it is 1, it has to satisfy both the properties, which means it can't break one of the properties. And I'm going to write that down because it gets a little bit hard to understand when you're looking at your notes later. So I'm going to write this. To be a probability distribution, PD, okay, it has to satisfy both of these rules. And in other words, you can't break one of the rules. I know that might sound intuitive to you, but for me, it doesn't. It's not very intuitive to me. All right, and as I'm looking at this, this looks like a Dunkin' Donuts ad just from the colors. I didn't do that on purpose, I swear. Okay. All right, let's do an example and take this abstract concept that I wrote down and turn it into something that can be applied. Okay. Here we have a probability distribution. Up top, we have all the different outcomes. So we can have a 1, a 2, a 3, or 4. And below, we have the probability of one thing happening, a probability of 2, a probability of 3, and 4. Okay, let's check our first property and see if this is a probability distribution. Okay, now it says that all the probabilities have to be between 0 and 1. Is that true? Look a little closer. All right, which probability is it between 0 and 1? The negative one, right? If you look a little closer, there's a negative sign to that 0.3. All these probabilities have to be between those two numbers. Negative 0.30 is less than 0. So property 1 is broken, okay? Now that I've checked property 1, do I have to check property 2? No, because it already broke the rule. This is not a probability distribution. Let's do another one. Okay, so example 5, we have another probability distribution. Let's check rule 1. Are all the probabilities between 0 and 1? Yep. Let's take a look. Well, there are negatives in here. So why does it follow rule 1 then? Yeah, right. These guys are X values. Everything on the top is an X value. We're not looking at the X values and trying to see if they're negative. We're looking at the probabilities. So I'm going to check this one, this one, this one, this one, this one. All of those are between 0 and 1. Okay, we're done. Okay. Let's check rule 2 then. Rule 2 says if I sum up all the probabilities, it's going to add to 1. In other words, if I take my 0.17, add on my 0.25, add on the 0.31, add on the 0.22, add on the 0.05. Did someone add these up already?
Yeah.
What'd you get? It's 1, good. So this sum is 1. Is this a probability distribution? Yes, right? Yes, it is a probability distribution because we checked the two rules and they worked. Any questions on example 4 or 5? All right, why don't you try example number 6? Shouldn't take too long, but I'll give you a few minutes to process this on your own. Here, we have a different chart here, and we want to see if it's a probability distribution. Lael, do you kind of want to take us through your steps here?
So for the one, I checked that all the
Mhm. All less than 1, right?
One,
Yeah, you're good.
The second one, I was trying to add them all up to see. It adds one and it adds 1.94.
Perfect job. Our sum isn't 1, then we're not a probability distribution. Any questions on example 6? All right, let's flip over to the next page here. We don't have to be just given a probability distribution. We can actually create our own. I'm gonna give you a simple example and then we'll get a little bit harder as we go on. We have a die and it's loaded. Who knows what a loaded die is? Have you ever been to like a casino? Actually, that's probably a bad question to ask you guys, but probably not a lot of you. At casinos, sometimes what people do, and my research was kind of on this a lot, casinos don't want you to win, right? When you go there, they want you to lose and keep playing, right? A lot of the times with games involving dice, they'll load the die. And what they'll do is they'll make like one side of the die heavier so that like it's more likely to land on a specific number than another one. So for example, this die is loaded so that it looks like one has the highest probability of being chosen. And it looks like 2 has a 1/6 probability, and then 4, 5, and 6, and 3 have a very low probability of being chosen. So as you roll this dice over and over again, you're probably going to get a lot of 1s and not a lot of like higher numbers. Okay. And casinos do this a lot just to make you lose a little bit more. But I digress. So when we construct this probability distribution, what do you think the X values or like the outcomes are going to be? On top, and what values are they going to be? Yeah, 1 through 6, right? Because that's where the actual outcomes are going to go. 1, 2, 3, 4, 5, and 6. And then on the bottom, we'll put the probability of each of these outcomes. So we'll have a half, a 6, and a bunch of 1/12, right? Now, if you really want more practice checking to see if things are probability distribution, you can check the 2 rules. It does pass. But let's go on. I think that one was pretty self-explanatory. Let's go to example 8. Let's say we have this box and it has a lot of money in it, which is nice. So we have 3 $1 bills, 2 $5 bills, a $10 bill, and a $20 bill. Okay. I want to select one bill out of it. What do you think my X values are going to be this time?
5, 10, and 20.
Yeah, right. Those are the things that can happen. I can either pull a 1, a 5, a 10, or a 20. So 1, 5, 10, or 20. Now I tried to trick you guys and I added a few other columns. Let's erase those. Okay. Before we find the probabilities of each of these guys, why don't we find the total number of bills in the box? So how many dollar bills are there in the box? I think I heard it 7, right? There's $7 bills. So if there's $7 bills total, what's the probability of choosing a 1? We got a 7, good. What's the probability of choosing a 5? 2 out of 7. A 10, 1, 7, and a 20. Perfect. Okay. And of course, we can create our probability distribution in this way. All right. Any questions on probability distribution? A new type of topic, but I think it's not too bad. We'll get a little bit harder as we move on with this. But for now, I think we have a quiz, right?